guys, it is the last week of school. I hope you're doing well and I hope you're ready to finish strong. We're Wolverines and we're gonna go right to the end. Today is kind of a busy day for us. We are gonna go ahead and review 7.5. Those were the notes that you looked at on Friday, and then you had a book assignment. I know there's a lot of different ways to approach these problems, so I thought a good thing to do on a Monday is go ahead and review how we can solve exponential as well as logarithmic equations. And then today there is an optional Zoom meeting. So if this is challenging for you or you want to see additional examples, please jump on the Zoom call and I will help you out. And then your assignment for today is just to continue practicing these skills. So we're staying on 7.5 for the day and you will be working on a worksheet. All right, so without further ado, let's just do a short review just to get the concepts back in your mind. So 1 and 2, what you're doing is you're solving what's called an exponential equation. An exponential equation means that your variable is located in the exponent. The first thing that you want to do is see if it's possible to make a common base. What that means is you have one base on each side of the equation and the base is the same. So like number 1, it's ready for you. This is a base of 5, this is a base of 5. If that happens, you can simply cross off the bases. So my equation is 2a minus 1 equals 3. Now from here you just have to solve. And remember, solve means to isolate the variable. So to move my minus 1 to the other side, you add 1. What you do to one side, you always do to the other. I would have 2a remaining. 3 plus 1 is 4. I'm not done yet because you have to solve. So a needs to be by itself. This is 2 times a. So to undo multiplication, we divide. Again, notice what you do to one side, you always do to the other. 4 divided by 2 is 2, and you are done. Okay, now number 2 is another one where we can get a common base. Sometimes they're not ready for you. Like number 1, it was awesome. They were both 5s. Here, 625 and 125, they can both be created from a base of 5. And what I mean is like 625, that is 5 to the power of 4. So if I go ahead and I go 5 to the power of 4, you'll notice that it has a value of 625. So what that means is I can change 625 to 5 to the power of 4 because these two things are equivalent to one another. I still have my exponent 2r. Now 125, you guys, is 5 to the power of 3. So if I know, or if I go ahead and plug this in, you'll notice 5 to the power of 3 is 125. So I can replace 125 with 5 to the power of 3. Now the reason why you'd want to do this is because now I have a common base. If you have an exponent inside and outside of parentheses, remember you multiply them. So this is 5. 4 times 2r, your exponent is 8r. Now remember your exponent properties. If you ever have something in the bottom of a fraction, it means that that exponent is really negative. So this is 5 to the negative power of 3. The negative is what would put that on the bottom of a fraction. This has one base of 5. This has one base of 5. The 5s can cancel. Your equation is 8r equals negative 3. You just take the two exponents, set them equal to one another. Now to get r by itself, I have to undo 8 times r. So to undo multiplication, we go ahead and divide. You can just keep it as negative 3 over 8. You can keep it right in that fraction form. So these two examples were how do you solve exponential equations by creating a common base. The next two, these are examples where it's impossible to make a common base. I can't have the same base to make 9 and 36. 9, I could go 3 squared, but if I take 3 squared, I get 9. 3 to the power of 3 is 27. 3 to the power of 4 is 81. It never gets to 36, so it's not possible. So what you do in this case is you take the log of each side. So again, if you cannot make a common base, you take the log of each side. So the log of 9 to the power of p equals the log of 36. there is a rule that says you cannot have an exponent on a log. So once you've changed this into a logarithm, that p has to come out front. P times the log of 9 equals the log of 36. I'm trying to solve. That means I want p by itself. When you send this exponent out front, this becomes a product, meaning you're multiplying. So to undo the multiplication, we need to divide. So now p would be by itself. Notice it says that we're rounding to the nearest hundredth. We figured out how you can enter this into the calculator when we talked about that change of base formula. So let's go ahead and do this. So on the top, I have a log. It opens a parenthesis. You want the log of what? 36, close it. So that's the log of 36. I'm going to divide it by the log. It opens a parenthesis. The log of what? A 9, close it. And if we round it to the hundredth, 1.63, and we're done. Notice that I did use an approximate symbol here versus an equal sign. It just means that I had to do some rounding. One more like this, and then we'll go ahead and look at logarithmic equations. I cannot make a common base with 6 and 91. So step 1, you take the log of each side. Remember, what you do to one side, you do to the other. So I did have to take the log to each side. There is a rule. Once this is a log, you cannot have an exponent. So that exponent comes out front, creating a product. So I have x times the log of 6 equals the log of 91. To solve, I need to undo the product. To undo multiplication, you divide. Again, it says that we are going to be rounding to the hundredth, so I can go ahead, plug this into the calculator. I have the log of, our numerator is 91, divided by the log of 6. Rounding to the hundredth, I have 2.52. So those 4 questions really reviewed how do you solve exponential equations. There are 2 methods. Method number 1, create a common base, then you're able to cross that base off. Method number 2, if you cannot make a common base, you take the log of each side. Okay, now the next 3 examples, we are going to look at how do you solve how do you solve logarithmic equations. A logarithmic equation means that you have a logarithm within the problem right away. You're not putting it there to offset that you can't make a common base. This is a logarithmic equation because you have the log at the beginning of the problem. Okay, I hope that makes sense. So if I'm looking here, you can still do the same thing where you have the same base. So if I have 1 log on each side, and remember this little number right here is called a base. If they have the same base, you guys, you can just cross that off. Same thing as when you're solving an exponential equation. If you have a logarithmic equation where you have 1 log on each side and a common base, they undo one another. Your equation is 2k minus 8 equals k. I don't want k's on both sides. So if I minus 2k, I would have negative 8. 1k minus 2k is negative 1k. You have not solved this yet. Solve means the letter has to be by itself. This is the same thing as negative 1 times k. So I need to divide both sides by negative 1. Negative divided by a negative is a positive. 8 divided by 1 is 8. So there's an example of a logarithmic equation where you have the same base. Now the next 2, one thing that you want to remember is that if you go to solve a logarithmic equation, you do have to make sure that you simplify it as much as you can. What that means is if you have more than 1 logarithm on one side of an equation, you want to condense them using the properties that we covered in 7.4, okay? So if I look, this side has a log, this side has a log. They are both a common log, meaning it's a base of 10. Because they have the same base, I can write them as 1 log. Subtraction goes with division, so this is really x divided by 2 equals the log of 31. Now it's the same as number 5. We just had to condense them first. This side has 1 log, this side has 1 log. They both are a common log, so you can go ahead and cross them off. X over 2 equals 31. Remember, a fraction, it actually represents the operation of division. So in order to undo division, you have to multiply. 31 times 2 is 62 when you're done. Last question. Again, if you have more than one log on one side of an equation, you have to condense them. This is a log base 10, this is a log base 10. Because they're both a common log, that's why you can combine them. You have to have the same base. Adding goes with multiplying. So I have to multiply 8 times x, and I would get 8x equals 1. Now this time I can't just cross off the log because I don't have a log on the side. So what I need to do is cancel it by using an exponent. Because there was not a base here, remember that's an unwritten base of 10. So this is a log base 10. In order to cancel a log with a base of 10, you need to give it an exponential base of 10. Because 10 to the log base 10 cancels, so I would have 8x equals 10 to the power of 1 is 10. In order to solve for x, divide both sides by 8. 10 divided by 8 is 1.25. So that was just a really quick review going through what we covered on Friday. Again, if you are having any difficulties, please join me on the Zoom call. Otherwise, today is a worksheet to practice these skills a little bit further. Talk to you guys tomorrow. Bye.